So I want to remind you guys, when you look at this bell work, that this is dealing with a system of equations. It even says system of equations right here. And you guys learned about this in Algebra 1. And what you learned about was stuff, primarily it looked like this. If you had, so that's a coordinate plane real quick. If you have two equations that look like that, the solution to this system of equations is where these two intersect. And there's one solution here at that intersection, and that's the only solution. Now, that's what we get most of the time, but there can be other situations. So we could have a situation where if this is your original line, you have another line that's parallel to it. That's supposed to be parallel, at least. It doesn't look very good. But pretend that that's another equation and it's parallel. So now these lines never intersect. So there is no solution. This is what we'd say is no solution. And so we either have one solution when they intersect at one spot, no solution when they never intersect at all, or we can have a situation where there's an infinite number of solutions. So let's look at how that would happen. You get an infinite number of solutions when the two lines are exactly the same and every single point coincides. So not only is it a parallel line, it's a parallel line with the same y-intercept. So you probably can't really tell what I did, but I drew another line right on top of the other. I mean, it should look exactly the same. But we have two equations that are exactly the same, which means no matter where we find a point, it's going to be a solution for both. Infinite number of solutions. And keep in mind that an equation right here, when we graph it, that is showing us the set of all solutions to that particular equation. So every point is a solution to that equation. All right, so we want to figure out, how do I get these two equations to be exactly the same? So I was just setting it up a little bit. Let me now kind of clear all this. I basically want this equation up top to equal the equation on the bottom. And there's a number of ways we can approach this. But the first thing I want to do is I want to figure out, if I notice this, sorry, I'm not speaking very clearly right now. There are multiple ways we could look at this, and this is just one way, and I'm just going to call it good. I noticed that if I multiplied this entire equation by 3, and we learned a couple of techniques in Algebra 1. One of them was substitution. If you remember having to use substitution to solve a system of equations, and then elimination. So what we have is a situation where if I multiply by 3, that means multiply everything in this equation by 3, scale it up, then this is going to give me 6x minus 3y equals 24. And what we're looking for is an equation where these two are exactly the same. I don't need to worry about rearranging this, but what I can see is that these are the same equations right here on the left, 6x minus 3y. So if it's the same on the left, I need to make sure on the right side it's exactly the same as well. So 4a has to equal 24. So does this make sense, kind of the logic behind the problem? Okay. So at this point, now it's a really straightforward problem to solve. 4a has to equal 24. A equals 6. So if, and there's your answer, if a equals 6, then this is going to be two parallel lines that happen to land right on top of each other. Every single solution to one is going to be a solution to the other. So there's an infinite number of solutions. All right. And that's the heart of this problem. Okay. So it is important. Sometimes we're going to have problems like this as part of ACT prep, where it's going back to some concepts that you've definitely slept since then and forgotten about. And it's okay if you just completely have forgotten. But that's why I want to cover these. I thought it was worthwhile to look at this so that we could review some of these things that you haven't seen, at least in a very long time. So we're going to be looking at area and perimeter of triangles today. And maybe, well, actually, the first thing I want to say is that the perimeter is not as important. I made that point yesterday. It's going to be kind of every once in a while, I'll ask you questions about the perimeter, but sometimes the perimeter doesn't matter. And I'll make it very clear. And I'll make sure if there's a problem on your test where you need to find the perimeter, you have all the information you need. But there could be problems where I just say, just find the area, just find the volume. I don't care about the perimeter at all. So knowing that, let's kind of look at this. Area and perimeter of triangles. So I want to start with the perimeter here. Knowing that the perimeter, knowing what the perimeter is, and we talked about this yesterday, I just want someone to write down the answer of what the perimeter is. And I'm going to pretend that all these are in feet. So 30 feet. All right, and how do we find the perimeter? Anyone can say it.
13 plus 12 plus 5.
There it is. It's just the distance around. So if we have a side of 13, one of 12, and one of 5, one thing that I mentally kind of imagine is like, imagine I was walking this route. This is a route that was marked. You know, how far would I have to walk walk the entire circuit? It would be 30 feet. So there you go. Pretty straightforward with perimeter. Now we want to find the volume, or the area rather. And I'm sure a lot of you can know what to do, but I want to start with this. And what I want to remind you of is the area of a rectangle is base times height. And that's the same as a parallelogram, right? So and then the next thing I want to do is I want to extend this over to here, extend that down to here. And so from my original drawing, I just created a rectangle, right? So the area of this rectangle is the base times the height. So here's my base, the 12, here's the height, the 5, and when I multiply that together, I'm going to get the area of this rectangle. So based on this, and some of you might already have the formula that of the area of a triangle memorized, and that's good. But based on this kind of demonstration that we just looked at, what do you think the area of our triangle is going to be, the formula of it? There it is. There it is. So because we have two triangles that together form this rectangle, I only want half of that area in order to get the triangle. So we can write this two different ways. We could write it just like was mentioned, base times height divided by 2. We could write it as 1/2 times base times height. Personally, I tend to write it this way, but some people write it this way. All right. All right. So either one of these equations, either one of these formulas work. And you can certainly feel free to write it whichever way works better for your way of thinking. All right. So as far as it goes, I'm going to erase this stuff that we have written up here now. We don't need this to be a rectangle anymore. It can be back to a triangle. So what is the base and the height? What are the actual values we're going to plug in here? 12 and 5. There we go. Now it's important. This is something, maybe this triangle is pretty straightforward with the base and the height because we can see this right angle right here. But there will be triangles where it's tempting to pick the wrong value. You want to always make sure that your base and your height are perpendicular to each other. I want to keep making that point every single day because that's most likely where your mistake is going to end up being if you get an answer wrong. All right, so the base and the height have to be perpendicular, so 12 and 5. So at this point, that's the hard part of this problem. I'm not going to bother with the calculations part. The answer here is 30 when you're done. Right? So the perimeter and the area happen to be the same, except what's my unit for my area?
Feet squared.
Feet squared. There it is. For area, we're measuring the area inside, so you have to use square units. We talked about that yesterday. So once we get to this step of a problem, then it's just really straightforward. I'm not going to take time today going over that. Plug it into the calculator and you're done. But it's the setting up, getting to that point that's really going to be where we focus most of our time. Okay, so pretty straightforward. I don't know if I need to say any more about this particular problem. All right, so now we have this one. And I will keep providing this formula to you. Area of a triangle equals 1/2 times base times height, or base times height divided by 2. You just pick whichever one works better for you. And I just want someone to write in what our equation will look like. So this is another one that, yeah, they give us only 2 values. And they luckily give us the 2 values that we need. So it's pretty straightforward plugging it in. And here's the thing. Now, according to this, 7 was plugged in for base and 6 was plugged in for height. It doesn't matter. And you guys hopefully know that. The order that you do this doesn't matter. But as long as the 2 dimensions are perpendicular to each other, and in this case, they are. What is going to confuse people sometimes is, let's say that the problem is set up a little differently, where we don't know this value right here. And instead, they tell us this is 7 inches. And what a lot of people will do is they'll still just plug that 1/2 times 7 times 6, or 7 times 6 divided by 2. But if this was the side that we knew, that would be a slant height, and that wouldn't be the one we wanted. So we'd have to have some way of solving for our height in the middle. All right, I want to make that point over and over again. So let's look at the next one. So with this one, well, let me just give you the formula. I'm going to see if you guys can plug in the values. Oh, dang it. I didn't mean to do that. Oh my gosh, this is all going wrong. Let me just start over again. All right, so if you've got it, you can actually just, yeah. I'll just give it to you now. You can plug in what our formula should look like. All right. And again, we can find the answer from here, 10 times 14, 140. So it's going to be 70. So the hard part is getting this filled in. And this one hopefully is not a hard problem. I just wanted to show you this one because just like we saw yesterday a little bit with the parallelograms, the height of your triangle is not always found within the triangle itself. So if they had given me this length right here was 12, then it wouldn't matter because I couldn't use it because that is not a 90-degree angle. I would instead need to project this over until I get to a 90-degree height, and that's where the 10 meters is. So just the fact that that 10 meters is outside of the triangle doesn't make a difference. So there we go. The base and the height are still there. Okay, so these are kind of the simple, straightforward ones, which you will have some simple problems on the test when you take it. But then you're going to have some problems where you have to do some preliminary calculations. And what do I mean by that? I mean problems like this one. Okay, let me just start off with the area equals 1/2 times base times height, or base times height divided by 2. But now I want you guys to look at this a little bit and see if you can come up with a way of approaching this problem to solve for the area of that triangle. So I know you guys are looking at this, but a good starting point is to look at the formula we're trying to fill in. And let me go ahead and use the this version of the formula. But do we know one of these 2 values, the base or the height?
Yes.
Which one?
Base.
The base is what?
10.
All right, so we're off to a start at least. The base is 10, I don't know the height. So that's at least a starting point. As soon as I figure out the height, then, you know, it's a chain reaction at this point. So I do some kind of calculation over here to solve for the height. As soon as I know that, I plug that into here. As soon as I know that, I can find the area. All right. So now we just need to figure out what sets this chain reaction off is how do we find the height? And so think about that. If you have any thoughts, feel free to share them. Pythagorean theorem. Yes, that's an excellent idea. Now, let me go ahead and write the Pythagorean theorem down. Now, how do I plug these values in? And just as a hint, I want to remind you that this right here, those two sides are equal, what do we call this kind of triangle? Not equilateral, it's close to equilateral, but it's starts with an I. There it is, isosceles. This is an isosceles triangle, so we can use that to help us. And we'll need to figure out how to plug these values in, but, well, just look at it for a minute. See if you can come up with what we need to do as a next step in order to solve for the height. All right. So the idea that was just presented is to split this triangle in half. So let me go ahead and do that real quick. I'm going to draw, this is just the right half of our triangle. So this is the height, this is the 7 meters. So what is this bottom length going to be? 5, okay. And this is where the key thing is, and well, 5 meters, let me go ahead and write it that way. But the key thing with this is that this is an isosceles triangle. So when this line comes down where the height is, it's actually splitting the bottom into 2. So that's going to be 5. And that's going to be 5. All right. So this doesn't work with just any regular triangle, but it does work with an isosceles. Are you guys good with this so far? Okay. If there are questions that come up on any of these and you want to come back to it, certainly feel free to kind of mark this and say, part of this didn't make sense. Let's go back and talk about it some more. All right. So now that we have this smaller triangle, this half of the triangle, we can solve for the height. All right, and the idea was already thrown out for Pythagorean theorem. So go ahead and plug those numbers from this triangle into the Pythagorean theorem. And you can feel free to write that on the screen, what it would look like when you take the 5, the h, and the 7 and plug it in. So if this is our Pythagorean theorem, we can set this up. We can solve for h, and I'm not going to do that on screen. I want you guys to set it up, and I'll actually call this h instead of b, which, I mean, b or h, it doesn't really matter. But solve for the height, and as soon as you come up with an answer, feel free to write down what you come up with. All right, so we got 4.9 as the length of the height. And now, since we set this up at the beginning to have our equation, the whole idea was as soon as we know this height, which we just found, we can plug it back into that, and now we have it. So you can see the preliminary calculation is the harder part. So 10 times 4.9 divided by 2. And there you go, you have the equation. You can figure it out. And what do you get? There it is, 24.5. And what's my unit for this? Meters squared. Perfect. Okay. So when it's area, it's meters squared. Now we can find the perimeter on this one. What's the perimeter, real quick? There it is, 24 meters. Pretty simple for a problem like this. That's 2 in a row that's been pretty close to 24 meters, 24.5. So sometimes those values are way different. Just happen to be some random triangles where they weren't. Okay, this one maybe we can just talk about rather than run entirely through the calculation. But just to kind of see the full process again, I'm looking for the area of a triangle, which it seems like maybe you guys prefer base times height divided by 2. So I can keep writing it that way. And I'll just put this one off to the side in case some people prefer it. Maybe I'm the odd person who likes it the other way, but no worries. So base times height divided by 2. Go ahead and plug in what we already know for this equation. Okay, we know whether you want to call it the base or the height here, doesn't matter. We know one of the dimensions is 3.2 and the perpendicular dimension is this unknown right here. And we're not going to go through this entire problem. I just want to ask, what would we do to find that missing dimension? It's Pythagorean theorem again. So I'll just set this one up real quick. So b squared plus 3.2 squared equals 8 squared. And you could solve for b, and at that point, not only could you plug that in right here and then solve, but at that point you could also find your perimeter because you know all three sides. So that's essentially what we just did. The last one was actually a little bit more complicated. So just good to see more examples of that. So we now have 2 problems left. And we are going to find the perimeter of this, but actually you want to start, this is going to be one of these problems where finding the area might actually be a little bit easier than the perimeter. So the area is base times height divided by 2. And I'll just write it that one way. So let's start with filling in what we know, so we know what we still need to solve for. Okay. We know the height is 2. The other dimension, x, no, there it is x. We don't know, that's what we need to solve for, and then we're going to divide that by 2. So now the question is, how do we solve for x? Trigonometry. All right. And I'm just going to do this. Here's our reference angle. Someone can label our sides, hypotenuse, opposite, and adjacent. There we go. And I like seeing a bunch of labels on here, you know? So if I see 3 or 4 people labeling it, that's not a problem. Okay, so there we go. If we are solving for the, if we're solving for x, which trig ratio do we need to use?
Tangent.
Tangent. Okay, is that what you're going to say? Okay. Oops. So I'll just set this up in general. I'm setting it up as the general equation. Tangent of x is equal to the opposite over the adjacent. So now fill in our equation with our specific numbers. There it is. There it is. So now at this point, and that is a 2 up on top. So I'll just write over it to make sure that's very clear. So anyways, at this point, you have what you need. You can solve for x. So I'll just put x equals right here and we can get our answer. I see 3 people came up with 22.9. Remember, we are always rounding to the 10th place, so that's good. I got the same thing, so I agree. 22.9. So at this point, that can be plugged in, 22.9. I do want you guys to get into the habit of setting up your area equation first, because what's going to happen if you don't do that for some people is that you're going to start calculating something. You're going to get this 22.9, and then somewhere in that process, you might forget why you were solving for it. You're like, wait, is that my final answer? I kind of forgot. So that's what happens. Sometimes people are on their way. They're doing everything right, but they just kind of forget. They get lost in the process and they're like, am I done yet? Was there something more I was supposed to do with this number? So anyways, setting up your equations at the beginning is going to be key to making sure you follow the process through. So at this point, that shouldn't be, yeah, no, that was all good, 22.9. So now we've got our 22.9, and this is, really, we don't even need the calculator for this because the 2 and the 2 cancel each other out. It's 22.9 square feet. All right. So that's the area. we were able to do that with a little bit of trigonometry to help us. Now we want to solve for the perimeter. I know it's 2 on one side. It's going to be 22.9 on another side. Plus, well, I don't know that third side. So we need to solve for it. And I want to point out something real quick before we solve for this. This is not drawn to scale. This is really drawn to scale. It would look like this. So there's like 2 feet right there. There's your 22.9. And then here's the hypotenuse. And I want to point that out because when you see your answer for the hypotenuse, it's going to look a little weird. How do we solve for the hypotenuse? Yeah.
B squared plus Pythagorean theorem.
We can use Pythagorean theorem for that. Because now we know 2 of our sides, we can solve for the third. All right. Is there another way of solving for it? Trig. How would we use trig to solve for this? Hypotenuse and adjacent, you said?
Yeah.
Okay, we could do that. There it is. So cosine, and I'm just going to write out some equations real quick. Cosine of 5 equals your adjacent side, which is 22.9 over x. And then could we set it up with sine? What would that be on the right side?
2 over 1.
Yeah, I should have put y right there. Let me change that. 2 over y. So no matter how you set this up as Pythagorean theorem, as a trig problem, you can solve for it, but you're going to find you get a really strange answer. Well, you might find it strange. Depending on how you calculate this, I mean, it's going to be really, really close, but you might round this up to 23 based on which one you calculate. You might round it down to 22.9. And you might be thinking like, we already had a 22.9. That's really weird that we got 22.9 again. That happens, all right? And that's why I wanted to show you what the triangle looks like drawn to more to scale, because the difference between this length down here on the bottom and the hypotenuse is not very much, though the hypotenuse is slightly longer by a few hundredths of a foot. All right, so essentially you could put 22.9 here or 30, or sorry, or 22 or 23, man, I can't think, 22.9 or 23, and we could find the perimeter from there. I actually don't care about the number. I just wanted to go through how we get to that point. Okay, are there questions on this problem? Okay. See if there's any questions online. Okay. Let me clear this, and we have one more problem to look at. All right. So, you know what? I'm not going to write anything down. Actually, I'll just write this. So we know we're going to find the area. We know we could find the perimeter. And I'll tell you, we have the information we need, right? So my question is, when you look at this, what are some of your thoughts? How would you approach this? Go ahead.
You can use trigonometry to find your adjacent side. So AC.
There you go. So we could find our adjacent side if we wanted to call it X right here. And so Caden was even saying he was calling it the adjacent side, so he would already have the stuff labeled. So I'm just filling in the labels that he was mentioning. Trigonometry works. What does anyone else notice a different way of approaching this problem? I won't keep you lingering for too long. That's 60 degrees because this right here is, I don't need to write it, it's already written. That's 30 degrees and 60 degrees. Is this a special right triangle? The short leg is half the hypotenuse. Yeah. There it is. Yeah, and so this is one of those things. The trigonometry works. If you look at this and all you see is trigonometry and that works for you, do it. If you notice it's a special right triangle and you feel comfortable with those special right triangle rules, it can go a little faster this way. Because just like was mentioned, the hypotenuse, if I divide it by 2, I get 8 right here. And what's my long leg going to be now? So again, if the special right triangle rules don't really work well for you, you don't have to solve it this way. But all you have to do is multiply by square root of 3. So this side is going to be 8 square root of 3. So if I know those rules, then I can actually save myself a little bit of time. And it's a really quick calculation. But, you know, if you go ahead and solve, if I do the calculation up here for the trigonometry, which would be cosine of 30 equals x over 16, then I get 13.86, or I could round that up to 13.9 rather. And then if I do 8 times square root of 3 by using my special right triangle rules, I get exact same value, 13.9. All right, luckily we don't need to worry about keeping it in the radical form for these types of problems. Now at this point, we can just plug those values in. We didn't have the base of the height before, so now we can plug those in. In fact, I'm not going to do that part of it. All right, the key thing is solving for the values that we need to plug in. So I hope you guys are able to follow along with this. Is there any confusion on this last problem we did? Okay, I just wanted to show you there are multiple approaches to this if you choose to do it that way. Okay, with that, I will clear the screen. We can look at your homework just a little bit. It's going to be very similar to last night's homework. So it's going to be in Canvas, and I will jump over there real quick. So your first part of your homework, it's going to be doing all the odd problems, and notice they give you all the values you need. I know you're not looking at it very closely right now, but you do have all of the values you need. You don't need to worry about preliminary calculations. And when it asks for the type, don't worry about that. That doesn't matter to me. There is an answer key down at the bottom as well, so you can make sure you're doing that right. Homework 2 is going to be kind of like we had to do yesterday, where there's some extra calculations that we have to do beforehand. And depending on the problem, you know, you'll have to figure out what is required. Is it Pythagorean theorem? Is it some trigonometry? Can I use a special right triangle if I even care to? When you get down to F, if you don't want to do the special right triangle rules, you can just still use trigonometry and just convert this 8 times square root of 3 into a decimal, you know, if that makes your life a little easier. So there are lots of approaches to this, and I want to leave it up to you to figure out what works best for you. But if you have any questions on this, please come back to class tomorrow with, you know, specific ones you want to go over because it didn't make sense. If there were some problems from yesterday's homework that didn't make sense, now is a perfect time. We can go over some of those as well. So with that, I am done talking for the day, and you can have a great day. If you have any questions, stick around. Otherwise, I will see you tomorrow.